Here are some problems regarding time rates using differential calculus. Problem number 1. Water is flowing into a vertical cylindrical tank at the rate of 24 cubic feet per minute. If the radius of the tank is 4 feet, how fast is the surface rising? Let's use h as the height of water at specific time, and dh over dt as the rate of how fast the water is rising. Important tips to remember in dealing time rates: determine the items that are constant and variable. In this problem, radius is constant, while the volume and height of water is variable. And we have the volume of water at any time is 16 pi h. Derive the equation respect to time, and that is dv over dt equals 16 pi dh over dt. But the change in volume respect to time is equals to the flow rate, 24 cubic feet per minute. Substitute this value. And the value of how fast the surface is rising is 0.48 feet per minute. Now, I will show you how to store values in your calculators. Press Shift, then recall button. For example, store the value of flow rate, type 24, then Shift, store, then press the location you want it to be stored, for example, at B. Then, store the radius for at A. Assign dh over dt as x. Type your equation, by the way equal sign is alpha calc. Then Shift, solve, check the values, then solve for x equals, and you'll get your answer. A ladder 20 feet long leans against a wall. If the top slides downward at the rate of feet per second, find how fast the lower end is moving when it is 16 feet from the wall. Assign y as distance from the top of ladder to the ground, and x as the distance of the lower end to the wall. dy over dt is the rate of how fast the top slides downward, and dx over dt is how fast the lower end is moving. Now, let's first solve the value of y by Pythagorean theorem, and that is 12 feet. Another important tip, in dealing problem like this, find a way to generate an equation involving known and unknown items from your figures or drawing. In this case, we can use the Pythagorean theorem. That is, length of the ladder squared is equals to x squared plus y squared. Derive the equation. But before that, let's establish that the length of the ladder is constant and only y and x are variables when the ladder moves. And the result will be 0 equals to 2x times rate of x plus 2y times rate of y. By the way, the rate of y is negative, since y is getting shorter once the ladder moves. Let's use our calculator to solve for the rate of x. Store the given values to your desired locations. Then, type your equation with dx over dt as x. Shift, solve, check the values, solve for x, and answer is 1.5. Problem number 3. A ship sails east 20 miles, and then turns north 30 degrees west. If the ship's speed is 10 miles per hour, find how fast it will be leaving the starting point, 6 hours after the departure. First, it travels east with a distance, d1 of 20 miles. With the velocity of 10 miles per hour. And then turns north 30 degrees west. And this will be d2. The total time of travel is 6 hours. Solve for t1 and t2. Now, solve for the distance number 2. Back to the drawing, This line will represent the distance of how far is the ship from the starting point. By the way, this angle is 60 degrees. Now, we got this triangle. Let's assign this side as A, angle as alpha, D1 as B, and D2 as C. Solve for the distance A, using the cosine law. Use the calculator in solving A. And the value of A is 20 square root of 3, or 34.64. Store this value at A. Finally, we can now solve for rate of how fast the ship is leaving relative to the starting point, and that is the derivative of A, respect to time. Use again the cosine law, and this time, do the implicit differentiation respect to time. Angle alpha is constant. And the answer is 8.66 miles per hour.
Don tips.